Welcome all. This is lecture number 2 on the topic beta and gamma function part 2. In this lecture we will discuss relation between beta and gamma function and other properties and some examples based on these two functions. So what is the relation between beta and gamma function? Beta mn can be rewrite in the form of gamma function as gamma m into gamma n upon gamma m plus n. First result, prove that integral 0 to pi by 2 sin raised to power p theta cos raised to power q theta d theta equals to gamma p plus 1 by 2 gamma q plus 1 by 2 upon 2 gamma p plus q plus 2 by 2. This is the most important formula to solve definite integral. By this particular formula, if there is written only sine and cos or only sine or only cos, then we can apply this particular formula, but the only condition is the limits for the integral should be 0 to pi by 2. So how to prove it? We have beta mn equals to integral 0 to 1 x raised to power m minus 1 minus x raised to power n minus 1 dx. Now we can replace this x by sine square theta. So dx is equals to 2 sine theta cos theta d theta. So from here, if x is equals to 0, then sine theta or theta is also equals to 0. And when x equals to 1, then sine theta is equals to pi by 2 or sine theta equals to sine pi by 2 or theta equals to pi by 2. And 1 minus x will be converted into 1 minus sine square theta or cos square theta. So on putting all these terms in this particular integral, we get beta mn equals to integral 0 to pi by 2 sine square theta power m minus 1 cos square theta power n minus 1 into twice sine theta cos theta d theta. Or this beta mn can be rewrite in the gamma function gamma n upon gamma m plus n. This 2 comes outside the integration and this is sine raised to power 2m minus 2 and one sign is from here. So it will be sine 2m minus 1 theta and same as cos 2n minus 1 theta d theta. Now can we put 2m minus 1 as p and 2n minus 1 as q? So from here we get m equals to p plus 1 by 2 and n equals to q plus 1 by 2. So replace all these in this particular formula. So it will be gamma p plus 1 by 2 gamma q plus 1 by 2 upon gamma p plus q plus 2 by 2 plus twice integral 0 to pi by 2 sine raised to power p theta cos raised to power q theta d theta, or this 2 can be shifted into the left hand side of the gamma function in the denominator. So this is the required result. Result 2, prove that gamma n gamma 1 minus n equals to pi upon sine n pi. So to prove it, we have from beta mn equals to integral 0 to infinite x raised to power n minus 1 upon 1 plus x raised to power m plus n dx. So on putting m plus n equals to 1, so that m equals to 1 minus n. So beta 1 minus n equals to integral 0 to infinite x raised to power n minus 1 upon 1 plus x dx, and it has a direct value, that is integral 0 to infinite x raised to power n minus 1 upon 1 plus x dx can be directly equate to pi upon sine n pi. So beta 1 minus n can be rewrite in the form of gamma function as gamma 1 minus n gamma n upon gamma 1 minus n plus n equals to pi upon sin n pi. So it is gamma 1 and gamma 1 is equals to 1. So gamma n gamma 1 minus n equals to pi upon sin n pi. So it is the proof of result number 2. Now result 3, duplication formula. Prove that gamma m plus half equals to root pi upon 2 raised to power 2m minus 1 gamma 2m, m is greater than 0. It is also a important result and hence show that beta mm equals to 2 raised to power 1 minus 2m beta m half. So to prove it, we have from this particular phenomena gamma p plus 1 by 2 gamma q plus 1 by 2 upon 2 gamma p plus q plus 2 by 2 equals to integral 0 to pi by 2 sin raised to power p theta cos raised to power q theta d theta. Now see, here we required only m. First we can replace q equals to p. So we get gamma p plus 1 by 2 gamma p plus 1 by 2 upon 2 gamma p plus 2 by 2 equals to integral 0 to pi by 2 sin raised to power p theta cos raised to power p theta d theta. So it will be 2p plus 2 by 2 or p plus 1, and here this is sin theta and cos theta whole power p, and if we want to convert it into the sin 2 theta then we require 2 raised to power p here. So we can multiply by 2 raised to power p and take it inside. So it will be 2 sin theta cos theta whole power p, and we divide also 1 by the 2 raised to power p. So this entire function comes. Now we can rewrite it as sin 2 theta or 1 upon 2 raised to power p integral 0 to pi by 2 sin raised to power p 2 theta d theta. So if we let 2 theta equals to t, then theta equals to t by 2 or d theta equals to 1 by 2 dt. And if theta equals to 0, t equals to 0, and theta equals to pi by 2, then t equals to 2 pi. So replacing all these terms in this particular phenomena, we get gamma p plus 1 by 2 gamma p plus 1 by 2 upon 2 gamma p plus 1 equals to 1 upon 2p integral 0 to pi sin raised to power pt into 1 by 2 dt. And we have one definite integral property, integral 0 to 2a fx dx can be rewrite in the form of twice of integral 0 to a fx dx. So using this particular property, we convert this pi into the pi by 2, and this twice is cancelled by this 1 by 2. So 1 upon 2 raised to power p only remains, integral 0 to pi by 2 sin raised to power pt and cos raised to power 0 t dt. So now we can apply the particular phenomena of integral 0 to pi by 2 sin raised to power n theta and cos raised to power n theta d theta. So we can rewrite in term of gamma function as gamma p plus 1 by 2 gamma 0 plus 1 by 2 upon 2 gamma p plus 0 plus 2 by 2. So this 2 cancelled out by this, 1 gamma p plus 1 by 2 is cancelled out by the gamma p plus 1 by 2. So only gamma p plus 1 by 2 upon gamma p plus 1 in the left hand side remains, and in the right hand side 1 upon 2 raised to power p gamma half upon gamma p plus 2 plus 1 remains. So we can write this gamma half as root pi and replacing p equals to 2m minus 1. So we get 2m minus 1 plus 1 is 2m and 2m by 2 m. So gamma m 2m minus 1 plus 1, so only 2m remains, so gamma 2m equals to 1 upon 2 raised to power 2m minus 1, gamma half is root pi, and this p by 2 plus 1 is converted into the m plus half, or take this gamma m plus half into the left hand side and gamma 2m into the right hand side. So this is the required duplication formula. Now we have to deduce the second part of the property. So for the second part, we can multiply by gamma m to the both sides of equation 1. So after multiplying, how we can write it? Gamma m into gamma m upon 2 gamma m equals to 1 upon 2 raised to power m minus 1 gamma m, and this root pi again converted into the gamma half, and this is gamma m plus half. So it is beta mm, it is beta m half So we can rewrite in the term of beta m of, and when we take it into the numerator, the power of this function is converted into the negative. So it is 2 raised to power 1 minus 2m. So it is the required proof of second part of the basic property, that is the duplication formula. Now example 1, solve integral 0 to 1 x raised to power 4 1 minus root x raised to power 5 dx. Now this formula, this particular question is in the form of beta function. This particular problem is in the form of almost beta function. If we convert this root x into the x, then this will be in the form of beta function. So how to solve? We can let x is equals to t square, so that dx equals to 2t dt, and when x equals to 0, t is 0, x equals to 1, t is also 1. So integral 0 to 1 x raised to power 4 1 minus root x power 5 dx can convert it into integral 0 to 1. This x is replaced by t square power 4, and this root x will be t, because x, when we put x equals to t square, then root t square is t raised to power 5 into 2t dt. So take this 2 outside the integration. So it is t raised to power 4 to the 8, and 1 is from there. So t raised to power 9, and 1 minus t raised to power 5 dt. So it is almost in the form of beta function. We can rewrite it as integral 0 to 1 t raised to power 10 minus 1 1 minus t raised to power 6 minus 1, so that this the basic value of the integration does not change. Now it is in the form of beta function, because integral 0 to 1 x raised to power m minus 1 1 minus x raised to power n minus 1 dx is converted into beta mn. So it will be beta 10 6, or beta function can be converted into the gamma function. So twice of gamma 10 gamma 6 upon gamma 10 plus 6, or twice of gamma 10 is can be written in the form of 9 factorial, gamma 6 is in the form of 5 factorial, and it is gamma 16, so it can be written in the form of 15 factorial. So opening the factorial, and on simplification we get 1 upon 15,015. This is the required solution. So another example, find the value of gamma half. This particular property is already discussed in the previous lecture, but there was the another phenomena, and from in this particular lecture we will discuss this by the another phenomena. So from integral 0 to pi by 2 sin raised to power p theta cos raised to power q theta d theta equals to gamma p plus 1 by 2 gamma q plus 1 by 2 upon 2 gamma p plus q plus 2 by 2. So we have to find the gamma half. When we put p and q equals to 0, then we can get gamma half. So on putting p equals to q equals to 0, we get integral 0 to pi by 2 sin raised to power 0 theta cos raised to power 0 theta d theta equals to gamma 0 plus 1 by 2 gamma 0 plus 1 by 2 upon 2 gamma 0 plus 0 plus 2 by 2, or this will be integral 0 to pi by 2 d theta, and gamma half upon gamma 1, 2 gamma 1, and gamma 1 is 1, and the integral of d theta is theta under the limit 0 to pi by 2. It is 1 by 2 gamma half square, and when we put the limit, so pi by 2 minus 0, or pi by 2 equals to 1 by 2 gamma 1 by 2 square. So 1 by 2 cancelled by 2. So pi is equals to gamma half square, or gamma half equals to root pi. So this is the another method to find the value of gamma half, and it is the easiest method than the previous one. Example 3, evaluate integral 0 to infinite dx upon 1 plus x power 4. So how to solve it? This is also in the form of beta function, almost in the form of beta function, x raised to power n minus 1 upon 1 plus x raised to power n plus n something. So if we convert this x raised to power 4 in term of t, so we let x raised to power 4 equals to t. then x equals to t raised to power 1 by 4, or dx equals to 1 by 4 t raised to power 1 by 4 minus 1 dt. So on replacing, and when x equals to 0, t equals to 0, x equals to infinite, then t is also equals to infinite. So no updation in the limits. I mean, limit same remains as it is. So this 1 by 4 comes the outside of the integration. So integral 0 to infinite t raised to power 1 by 4 minus 1 dt upon 1 plus t. Or but we have integral 0 to infinite x raised to power n minus 1 upon 1 plus x dx is equals to pi upon sine n pi. So replacing it, so 1 by 4 pi upon sine pi by 4, and sine pi by 4 is sine 45 degree, which is 1 by root 2. So we can write it as pi root 2 by 4. So this is the required solution. Now you see this particular integration is solved by the with the help of beta and gamma function in a very easy manner. Example 4, prove that gamma 1 by 4, gamma 3 by 4 equals to pi root 2. We have from gamma n, gamma 1 minus n equals to pi upon sine n pi. So we can put n equals to 1 by 4 here. So when we put it 1 by 4, gamma 1 by 4, gamma 1 minus 1 by 4 equals to pi upon sine 1 by 4 pi, or gamma 1 by 4, gamma 3 by 4 equals to pi root 2. So this is the required solution of this particular example. Next example, prove that beta p plus 1 q plus beta p q plus 1 equals to beta pq. So to solve it, we can take left hand side. So beta p plus 1 q plus beta p q plus 1 can be rewrite in the form of beta p plus 1 q can be rewrite gamma p plus 1 gamma q upon gamma p plus 1 plus q, and beta p q plus 1 can be rewrite gamma p gamma q plus 1 upon gamma p plus q plus 1. Now applying the property gamma n plus 1 equals to n gamma n, we can rewrite this gamma p plus 1 in the form of p gamma p, and same as p plus q plus 1 can be written in the form of p plus q gamma p plus q, and this gamma q plus 1 can be written in the form of q gamma q, and this is also p plus q gamma p plus q. Now see here, in the both cases gamma p gamma q upon p plus q gamma p plus q is in the common, or we can take only gamma p gamma q upon gamma p plus q as a common. So p upon p plus q and q upon p plus q remains in the bracket. So when we take LCM, then it will also be p plus q. So p plus q is cancelled out by the p plus q. So only gamma p gamma q upon gamma p plus q remains, and it is the beta pq. So which is the right hand side. So we have proved this particular problem. Hope you understand this entire phenomena. We will meet in the next lecture with remaining part of this particular topic, that is how to solve multiple integral with the help of beta and gamma function, that is the Dirichlet's theorem and extension of Dirichlet's theorem. We will discuss it into the next lecture. Thank you.